We would like to look at graphical display in terms of a scatter plot for this data that we have obtained from fueleconomy.gov, which shows in this column miles per gallon for a for a vehicle of a type, and the carbon emissions in tons over the vehicle's lifetime. Okay, so to see how does graph of a data of this kind of data look, let's press on insert and then we go to scatter plot, and we have created this scatter plot. Now let me erase these here. Okay, and we can put the axis titles here. That is, just go to layout, go to axis titles, and we want the horizontal axis title to be below this, and yeah, it would be good to increase the font size a little, as well as the chart area. For here we extended it. Okay, and the axis title here is what? The miles per gallon for this kind of a vehicle. Okay, then let's choose layout again, and we want the vertical axis title. I like it better this way when it's aligned like this. So, but you can make it whichever way you prefer. So what was the size before? Yeah, let's keep it 16. So we will say this is CO2 emissions, okay, in, tons over the vehicle's lifetime. So you can do that at your own time. Let's just quickly learn the other methods that we want to see. Okay, and if you would like, you can change the x-axis to start with 10, but right now I think it's all right the way it is. Okay, now let's, in order to obtain an equation of best fit for this relationship, we will go to layout again. Let's choose the trend line option, and we know a straight line is not going to be the best relationship for this the way it looks. So let's look at, for instance, here say at exponential. Okay, and there we are. Okay, I just asked for equation and also for the coefficient of determination. Okay, and here they are. Let me increase the size of this again. Okay, 1 second. Okay, so we will do it the same way as we did for the axis. Okay, so here we are. So this is exponential relationship. Okay, if you look at this, this is the exponential model, an exponential model fitted to this data. If you want, you can try some other model. Say for instance, we try, for example, this parabolic model, say. Okay, so we will say, well, fit a polynomial of degree 2. Okay, then we again ask for the coefficient of determination and the equation, and let me enlarge it here. Okay, so we have, one moment. So yes, of course, it's higher coefficient of determination, but notice this parabola has its minimum around here, so it may not be the best thing to do prediction even for some range over in this side. So I'll let you decide in your own project. Okay, so I just wanted to show you that how can you use Excel to obtain these equations. Okay, here we are looking at another data set. Here we have the length of a pendulum in centimeters and its time period in seconds, and we want to see through this experimental data that whether the time is proportional to the square root of length. All right, so what we will do again, we can go and look at our plot again. All right, so here is the plot. Okay, and we can resize this all, but right now let me just show you the, or let's just quickly review the fitting procedure. It'll be good to have what's that, the labels written beforehand, so I'll quickly write that. Okay, so here the title is length of the pendulum in centimeters. Okay, so we write it down, length, okay, in centimeters. Okay, and for the vertical axis, what we shall do is vertical axis, and I'm going to go as I did before by writing it as a rotated title. Okay, so where did we lose it? One sec. All right, so I lost it somewhere. Let me get that again. Okay, so here, then I want my vertical axis title rotated, right? Okay, in the size 16, and I'm going to write what? Time period in seconds. Okay, all right. Now when we go to fit an equation here, I'm going to go to trend line, and this time what I'm going to do, as I said, we want to see whether the y values are proportional to the square root of the x values. So I'll go for a power type of trend. Okay, and here we go. Okay, we have let me enlarge it for you. Okay, so you see this here, that the equation that we can fit to this trend here, you know, it tells us that y is according to like 0.1813 times x to the power 0.5175, which is not exactly the square root of x, but the thing is it's close, and you can read the article that I referred you to in the script, okay, to see it further. Okay.